Hello, this is Mr. Stansbury. I'm going to take you through the 6 notes on the remainder and factor theorems. At the end of this, you should be able to say that I can evaluate functions using synthetic substitution, and I can determine if a binomial is a factor of a polynomial using synthetic substitution. So, let's get into it. Let's talk about synthetic substitution. Now, you've done synthetic division before, and synthetic substitution is essentially the same thing, and we can use this to find the value of a function. All right, now we're used to finding the value of a function by just regular old substitution. For example, find f of negative 3 for the function f of x equals negative 3x squared plus 5x plus 4. Now the regular substitution method, we start with the formula and then we say, okay, we want to substitute in f of negative 3. So all the x's turn into negative 3. So we do negative 3 times negative 3 squared plus 5 times negative 3 plus 4. So f of negative 3 squared is 9, times negative 3 is negative 27, 5 times negative 3 is negative 15, and then we still add our 4. And when you add that all up, we get negative 38. So we get f of negative 3 is negative 38, and that works just fine. Now the thing is, we can actually use synthetic substitution to do the same, to come up with the same answer. So the way you do that is we do this. We start with the same equation, and then in our little box over here, we're going to put negative 3, and then we're going to bring our coefficients down. So we have negative 3 for the x squared, we get 5 for the x's, and then 4 for the constant. Draw our little line, bring the negative 3 down. Negative 3 times negative 3 is 9, plus 5 is 14, times negative 3 is negative 42, plus 4 gives us negative 38. And whatever the remainder is our answer. So if you look here, we get negative 38 there, and we get negative 38 there. So it's just a different way of doing substitution. So if you still like the old way better, that works just fine. But this is a little bit different way to look at it, and it might be easier for some folks. So let's put that into some other use here. So we're going to take a look at example 2, or a little hybrid of example 2. The Zores population in southern Liberia can be modeled by the formula P of t equals all this lovely polynomial here, where P is the population and T is the number of years since 1993. Find the estimated population in 2013. So what we want to do there is figure out, let's see, from 1993 to 2013 gives us 20 years. So what we can do with our synthetic substitution is put 20 in our box, and then we're going to bring all these coefficients down. So 0.02, negative 0.52, that's 4, 3, 2, 1, and 0. So we have all of our powers. We don't have to put any zeros in. 4.03, 0.09, and 78. And again, we're just going to do our synthetic substitution. Whatever we get for our remainder would be our answer. So we bring the 0.02 down, and then we're going to multiply that by 20. All right, so 20 times 0.02 gives us 0.4. So then this 0.4 goes right here, and we add that to negative 0.52, we get negative 0.12, right? So let's see, minus 0.52, and we get our negative 0.12, and then we'll multiply that again by 20, and we get negative 2.4. So then we got our negative 2.4 to the 4.03, so plus 4.03, we get 1.63. And then we multiply that 1.63 by 20, we get 32.6. And add a 0.09 to get 32.69. And multiply that by 20 again. 653.8. And then our last step is to add the 78 to that. And we get 731.8, so let's call it 732. So we will have about 732 sources in 2013. All right, so that would be our solution to that. Okay, let's take a look at one more example, and then away we go. So now, after those examples, you should be able to say I can evaluate functions using synthetic substitution. And then the last thing we're going to do is I can determine if a binomial is a factor of a polynomial using synthetic substitution. Okay, so we're going to determine if x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15. Okay, and then find the remaining factors of the polynomial. So what we're going to want to do here is we're going to set this equal to 0 like we've been doing with our synthetic division. So we're going to put 5 in the box because 5 minus 5 gives us 0. And then we're going to bring all our coefficients down. 1x cubed, let's see, we got cubed, squared, first power, 0 power, or constant. So we don't need to put any zeros in there. So there's negative 7, positive 7, 15. Draw our line, bring our 1 down. 5 times 1 is 5. 5 and negative 7 is negative 2. Negative 2 times 5 is negative 10. And 7 is negative 3. 5 times negative 3 is negative 15. And we get 0 for our remainder. So since we get a remainder of 0, this means that x minus 5 is a factor of the polynomial up there. Okay? So what that means is x cubed minus 7x squared plus 7x plus 15 equals x minus 5 times, and then whatever we have left here. So there's our remainder, there's our constant, that's our x, and that's our x squared. So all times x squared minus 2x minus 3. Okay? Last thing they asked us to do is to find the remaining factors of the polynomial. So, oops, that looks like 3, but it's 5. So this here should end up factoring out even farther, right? So x times x gives us our x squared, factors of 3, but have a difference of 2. Well, there's only one set of factors of 3, and that's 3 and 1. The sign here goes with the bigger of the two factors, and then this sign tells us that our factors are opposite signs. So this is the factored version of x cubed minus 7x squared plus 7x plus 5. All right? So that's all there is to that. If you have any questions, please ask. Thanks.